All right, lesson 4.02, the second lesson on this whole heat topic. I realize I left a word out here. You will learn about heat. All right, and we're gonna talk about heat. And we're gonna make sure that you know how it's different from temperature. Since it's not the exact same thing. They are different chemical properties. And really, you're going to be able to do this so that you can talk about how thermal energy moves. Alright? So, you will know you understand this when you can distinguish the two terms, heat and temperature. And you can describe how heat will flow between two objects that have different temperatures. Alright? So, really a follow-up to what we've already been talking about, just some more clarification and kind of like practice sort of stuff. So, let's get some definitions down. All matter has thermal energy. All right, so this is the energy related to the temperature of the matter. We've talked about this before. All right, temperature is a direct measure of what? All right, it's a type of energy that is related to the motion of the atoms. So think this one through, maybe look at, I think we defined this actually in the gas law notes. All right, but if this isn't familiar to you, you are definitely going to want to write this down again. But temperature is a measure of kinetic energy. All right, so thermal energy and kinetic energy are synonyms. They mean the same thing. All right, they refer to the same thing. Heat, on the other hand, is the transfer of thermal energy. All right, it's a measure of how much thermal energy is transferred. Now, heat will always go from where there is more heat to where there is less heat. All right, it's kind of like the concept of diffusion, where if you have like a smell concentrated in one area of the room, it disperses itself to the rest of the area of the room. All right, it's going from high concentration to low concentration. And it's going to keep doing that until everything has the same amount of heat, which would also mean that everything has the same temperature. All right? So, thinking about it this way. This is the quintessential example of heat transfer. So you cool a drink with an ice cube. In which direction is the heat traveling? Is it going from the water into the ice cube, or is it going from the ice cube into the water? Think about where the heat is concentrated. All right? We can use temperature to indirectly measure heat. All right? Higher temperature means there's more heat there. So, we're always going to go from what was in higher temperature towards something that was in lower temperature. So when you use ice cubes to cool your drink, what's happening is that the heat is leaving the liquid and going into the ice cube. All right? Because the ice cube has less thermal energy in it. That's why it's frozen. All right? So you can also think of it as heat transfers from the hot stuff to the cold stuff. It always goes from hot to cold. So, these are kind of like your note-taking sort of definitions. So thermal energy is your internal kinetic energy. All right. Just another quick review. All right. How does temperature relate to kinetic energy? As temperature increases, the motion of the molecule also increases. All right. Remember that one. All right. So thermal energy is the same thing as kinetic energy. Temperature is how we measure it. All right, so temperature is just our measurement. It's a way of being able to say how much kinetic energy is present. The higher the temperature, the more kinetic energy. Heat is the change in thermal energy. All right, so we can observe and measure heat when we see a change in temperature. All right, if everything stays the same temperature, then there's no heat going on. So if temperature increases, heat increases as well, or is gained. All right? Whereas if temperature decreases, then heat is lost. So eventually we're going to get into actual calculations. That's going to be coming up for the next quiz. Based on the 4.03 quiz, everything stays just kind of qualitative, just in general what's going on. So for this one, you place a block of dry ice, which is at negative 40 degrees Celsius, in contact with an ice cube, which is at negative 10 degrees Celsius. Considering only the interface between the two blocks, that means where the two blocks are touching, which of the following will happen? All right, so what it's asking you to do is determine which direction will the heat flow. All right, how is our change in temperature? What direction is that going to head in? So we've got the dry ice, which is at negative 40. The ice cube is at negative 10. So which one is hotter? Has more thermal energy in the first place? So paying attention to your negative numbers, you should pick up on the fact that the ice cube is actually the one that has more thermal energy. So that means that that energy is going to flow from the ice cube into the dry ice. So your heat goes in that direction. All right, so heat goes from the ice cube into the dry ice. All right, another kind of question that you're going to see, just kind of tying everything together. So your body produces heat all the time, but where does it come from? So think this one through. Where do we get our thermal energy from? Hopefully you're thinking about where you get energy from, and that's from eating. All right, and then our body takes all of those chemicals in the food, breaks them apart, and those bonds break, that releases energy that our body can use for things.